Hello, in this video we will present the Minsait Cloud Continuum Orchestrator, or MCCO, developed with funds from the government of Spain. In particular, the development has been carried out within the activities of the 6GSMART project, led by the i2CAT Research Center in Catalonia. This orchestrator allows us to deploy applications for Industry 4.0 using an intent-based model that provides the end user with several options to locate the components that are part of the application on the clouds defined in the system. Now, in this demonstration, we will deploy Minsait solution for the management of IoT devices called Minsait Platform. Once this solution is deployed, we will implement a simple use case that consists of storing temperature and humidity data in the central database from a simulated sensor. The Minsait solution application consists of two elements, Minsait Platform and Minsait Local. Minsait Platform is a generic data processing solution from Minsait. It can also collect data from IoT devices. It is composed of three components, Minsait Base, Minsait Engine, and Minsait Broker FE. All of them have different internal modules as well. These three components are usually deployed in an environment with sufficient computing capacity and availability. Minsait Local is a distributed part of the solution, whose composition will be analyzed later on in the use case presentation. In this demonstration, we will deploy in a Tecnologies cluster an instance of its component that is part of the Minsait platform element. The use cluster provides the necessary resources to run the application with an appropriate level of availability. Meanwhile, the local component will be deployed in its factory premises, in this case, 2 instances. To enable communication between components located in different clusters, the orchestrator will create a Level 7 application virtual network, using Scapper technology for this purpose. With this, each component will be able to access the service offered by a component in a remote cluster as if they were on a local Kubernetes service. Next, we'll define the Minsait solution application in the orchestrator, as well as the clusters to be used. And finally, we will create an instance of the application. The first thing we will do is to define the clusters that will be used, also called clouds. As mentioned earlier, we will create a telco edge cluster where we will place the central application component, and 2 on-premises clusters where we will place the distributed component Minsait local. We will label each cluster accordingly for later use by the orchestrator. Now, using the JSON files that we have shown in the presentation, we will proceed to define the clouds. So at this moment, we see that there are no clouds defined, and we will proceed to define the first one. We see that it's already created, so we will create the second and the third one on the same way. We can see here that the 3 clouds have been created. The next step is to incorporate the components that are part of the solution into the orchestrator data model. To do this, we will define the corresponding Helm repositories and the Helm charts to be used from each repository. In our case, we will use the standard on-site repository for the Minsait base and the Minsait engine components, while for the Minsait broker fee and Minsait local components, we will use a local repository where we have uploaded 2 Helm charts. Those Helm charts have been implemented for this demonstration. Now we proceed to incorporate the components. So to define the components, we will send an instruction like this one, setting the parameters here. The name of the Helm repo, URL, as well as the chart name, and the chart version in case we need to specify a different version. Define the first component, and the same for the second, third, and fourth component. All of them have been created, and now we can check the list of components in the application. Now we've defined the application components. It's time to define how the deployment should be performed. For each component, we need to define a deployment. So we mainly need to specify the name of the component to be deployed, the deployment model to be used. In our example, we'll use 2 deployment models. per cloud level and anti-cloud level. With the per cloud level model, the orchestrator will deploy a Helm chart instance in each cloud tagged with the indicated level in the deployment. For the anti-cloud level model, n instances, which are indicated in quantity, will be deployed across the set of clouds tagged with the indicated level in the deployment. The service is exposed by the Helm chart, so it can be exposed over the level 7 network. In our case, only the one-step broker FE component exposes a service, and the connection that the component has with the other application components. In our case, there is only one connection from the one-step local component to one-step broker FE to access the provided service. We'll proceed to define the application now by using the JSON file, which is basically what we have seen into the presentation. So to define the application, we will run the following instruction. The application has been defined properly, and once the application has been defined, we will define the connection. Connection has been defined. We can check the application now. Everything looks correct. At this point, we have defined what our application is and how we want it to be deployed by the orchestrator. So we're ready to deploy an instance of the application. Here you can see 4 different windows. One of them is to monitor the OneSet platform cloud. 2 of them are to monitor OneSet local, and the 4th window is to run the instruction for the instantiation of the application. So we will start running the instruction and then we will monitor the process. Instance created, then check the status. The namespace has been created in the 3 clouds, and we see that currently it is installed in Scapper in all the sites. So once Scapper has been installed, then it will start the installation of Scapper links. Once the links have been created, it will start installing the charts. This process is going to take some minutes, so we'll stop the video now and we'll resume once this is completed. Now all the components have been deployed. If we check here the status, we see that it's in status ready, and we can see that all the components are in status running or completed throughout the different clouds. So at this point, once the application has been deployed, we will implement a simple use case. The use case consists of simulating a sensor that collects temperature and humidity data, sending that data to the OneSet local component. This component sends the data to the central database where we can view it. So first, we will access the Solutions control panel to define an ontology with the data to be collected. We are now in the control panel. Here we need to create an ontology. To create the ontology, go to Entities Management. We'll add a new entry here and we'll create it step by step. So the name will be IoT sensor. Meta information will be dummy, and description will be also IoT sensor. Click on continue, and for this ontology we will create an empty base with 2 attributes. One of them is temperature. This is a number data type, and the other one is humidity, also a number data type. So once they have been defined, we update the schema, and we can see here the schema. We can test it. Yeah, everything looks good. Then click on continue and then create it. We can close this window. So once the ontology has been created, we can go to the digital client definition. Once we have defined the ontology, we need to define the client data. This client data will be used by OneSet local to access the IoT broker in the central component, OneSet platform. So we need to click here to create a new one. We'll call it IoT sensor v1, Description will be IoT sensor. And here we select the entity that we have created previously, the ontology. Okay, so here at the bottom we've got the token. This token allows to identify the client when sending data. Now we need to save the changes. And we'll have here our client. With ontology and the client defined, we have everything that is needed in the OneSet platform for the use case. Once we have defined the ontology and the client data in the central platform, we will configure the local platform. Here we have three components. The MQTT service, which interacts with the devices. The flow engine, which receives the MQTT service events and sends them to the central platform. In this case, Minsait has developed Node-RED nodes to interact with the central platform. And the last component is Scapper to establish the communication between OneSet local and OneSet platform. Now we'll access the Node-RED module to configure our node with the data we collected from the central platform. So now we'll access again this client and copy the token. With this token, we'll access the Node-RED module of the Minsait local component. This will allow us to configure the client data. Here, in the OneSet platform insert, we'll use the token that we have copied already. So we need to define the client, which is IoT sensor v1, IoT sensor 001, we'll call it this instance, and here is the token. Update the parameters, done. This will allow us to insert data into OneSet platform. Then we need to click on redeploy. And now we'll simulate a sensor collecting data and sending it to the MQTT bus, which is part of the OneSet local component. Here, this one. This bus is used to receive sensor data. So we'll go to the console and then run the instruction. Now we can go to the debug messages and check the output. So here's the received message. We can confirm the reception of the data by going again to the control panel, query tool. We select our sensor and execute the query. So here we've got the entry and we can see here the temperature and the humidity. So we confirm our application is running properly. That's all. Thanks for watching the video.